Okay, so we're back for part 2 here, and we're on the second page, and we're going to do another example, number 2, graph f of x equals negative x squared plus 4. Now this time the table is blank. So this time we need to, or you need to figure out, okay, what x values do I want to try? Do I want to plug in? Now obviously you don't want to pick a number like 10 because we're not going to be able to graph that, so we need to pick numbers here. One thing that you can do to make this a little bit simpler is if you have a graphing calculator, or you could use Desmos, if you go to y equals, and I'm going to type the opposite of x squared plus 4, and I'm going to graph this. Let me get a look at it here, just so I can pick some values that I know are going to be nice to use. So it looks like most of these values are starting around really the origin point, so over here. So I definitely want to use 0. It actually looks like the vertex would be here, wherever that is. So some numbers I'm going to pick. Let me do a couple negatives. I'll do -2, -1. I'll do 0, 1, and 2. Okay, so let me do that. -2, -1, 0, 1, and 2, and that should give me the shape. What I'm looking for is I need to see this curve. So when I'm graphing, I don't want to pick only these points here because that looks like a line almost. So I want to see where it turns, I want to see the vertex, and then I want to see where it's also, in this case, coming down. Now you got to be careful here when you substitute a negative. So the function, it's the opposite of x squared plus 4. So when I substitute my -2 here, I square the -2 in parentheses first. Now that's 4. But this is like a -1. So this negative still comes down, so it becomes -4 plus 4, which is 0. Now you can pause this and go ahead and substitute these yourself and see how they work out. But I'm going to tell you that this is going to be 3, 4, 3, 0. So that's how it's going to work out. If you don't trust me, go ahead and plug those in and verify. So -2, 0, -1, 3, 0, 4, 1, 3, and 2, 0. So I definitely see that curve. It looks like the vertex is here. So I'm going to draw it. As long as I go through the points, it's fine. It doesn't need to be perfect. The domain is the set of x values, again. Now, because of the way this curves, it's going to keep going to the left. It's going to keep going to the right. So the domain is all real numbers. The range, though, the y values, this time, in this case, our vertex is what we call a maximum. So we have a highest value. So in this case, our y values, everything is part of the range until we get to +4, and then nothing above it, the function doesn't exist. So we're going to say all real numbers less than or equal to +4. And again, equal because this value, 4, is part of the range. Okay, if I write it as an inequality, I would say -infinity, because it goes all the way down, is less than y is less than or equal to 4. When I write the inequalities, I always go from low to high. That's how I write it. X-intercepts, we have 2 of them. We have it -2, 0 and +2, 0. Now, you are sometimes going to get decimals. These work out nicely, but that's not always the case. The y-intercept would be at 0, 4. And the vertex is also 0, 4. One more thing we'll write down here, the axis of symmetry. I'll just abbreviate that. The axis of symmetry is the vertical line that goes through the vertex. Now, in this case, that would be x equals, and where's the x value that we go through? 0. So that would be the equation x is equal to 0. Okay, so one of the things that you noticed is that I did use a graphing utility to help me with this, and that's something that you can definitely use if you have that. It just makes life a lot easier, at least to give you an idea of what your graph looks like. Now, the other thing that is really helpful is if you can figure out where the vertex is, the axis of symmetry, then you can always put that number in the middle of the values that you're plugging in, and then you can take a couple values to the left and a couple values to the right, and that's going to give you that curve. Because you know that the vertex, maximum or minimum, is always going to be that turning point on your function. Now, there's a short way of finding it, finding the axis of symmetry, and it's this equation, x equals, it's the opposite of b divided by 2 times a. Now, the a and the b come from the function, come from a quadratic function, ax squared plus bx plus c. So your b value is there, and your a value goes there. All right, so let's go ahead and use that to try to help us here. Find the vertex, the equation of the axis of symmetry, and the y-intercept of the graph of each function. Okay, so we've got, this is y equals, f of x equals, that's 1x squared, that's your a value is 1, plus 6, that's your b value. Now we don't need the c, we don't need the constant, but if you did, it's -7. The equation for the axis of symmetry is the opposite of b divided by 2 times a. So that would be the opposite of 6 divided by 2 times 1. So 2 times 1 is 2, and -6 divided by 2 is -3. Okay, so first of all, the axis of symmetry is x equals -3. That's the vertical line. Now, if you want the vertex, you already have the x value in the vertex. We just need the y value. So how do I find a y value? Well, I can always take an x value and substitute it into the equation. So I'm going to do the function f of -3. So it was x squared plus 6x minus 7. And now I'm going to substitute -3, and I'm going to work that out. So that would be +9 minus 18 minus 7. 9 minus 18 is -9. Subtract 7, and you get -16. So the vertex is a point. So it has to be x comma y. The x value is -3, and the y value is -16. Now, just to show you, hey, did we do that correctly? Well, let me check it on here. So it was x squared plus 6x minus 7 graph. Now you can see here's the parabola, it's going down. So somewhere below is where that turning point is, where that minimum, that vertex is. Now we say it's at -3 for x, and now down 16. That actually looks like we're going in the right direction here. If I zoom out, I mean, we can approximate, that looks okay. So I think this number makes sense here. So we found the vertex, we found the equation of the axis of symmetry, we want the y-intercept. Well, that's easy because the y-intercept is where x is equal to 0, because it's 0 comma something if you're on the y-axis. So what we're going to do is take our function and we're going to evaluate when x is 0. So it's x squared plus 6x minus 7. We're going to put a 0 in there. Anything 0 squared is 0. Anything times 0 is 0. So we get -7. So the y-intercept is 0 comma -7. And that's it. All right, let's do one more example here. Again, I would go ahead and pause it, see if you can work this out yourself, and then unpause and see if I get the same answer. All right, we've got A, -3. We've got b is +12. The equation of the axis of symmetry, x equals the opposite of b divided by 2a. In this case, that's the opposite of 12 divided by 2 times. Now a is a -3. So that's -12 divided by -6, which is +2. So the axis of symmetry, x equals 2. To find the vertex, we now take 2. We need to find the y value, the y coordinate, so we plug a 2 in. So we're going to do f of 2. So -3 times 2 squared plus 12 times 2 plus 5. Instead of x, we are substituting this value. 2 squared is 4 times -3 is -12 plus 12 times 2 is 24 plus 5, and we end up getting 17. So the vertex x comma y is 2 comma 17. Now, have I done that correctly? Well, let me go to my calculator here. Check this out. So the opposite of 3x squared plus 12x plus 5. All right, now notice that this parabola, this curve, is opening down. So we actually, from left to right, we go up, we turn, and we come back down. And so the vertex is somewhere up here. Now we think it's at 2 comma 17. Well, if x is 2 spaces, that actually looks pretty good for the x coordinate, and I think 17 is also okay. Now the last thing we want, though, is the y-intercept somewhere around here. So for the y-intercept, we're going to plug 0 in for x. All right, I always set up my function. I put the parentheses. For my x's, I'm going to put 0 in. This whole thing is 0. This whole thing is 0 plus 5. And what we get is 5. So the y-intercept is 0 comma 5. And that is the end of part 2.